everyone. My name is Petar Gjorgievski, and I work as a DevOps engineer at Scalefocus. I would like to thank you for joining and dedicating your time to our event. Hopefully you will enjoy this presentation, have fun, and maybe even learn something along the way. Before we start, I would like to share some more details about the Tech Savvy Talks initiative hosted by Scalefocus. This is our second event of the series. The event takes place every 2 weeks. And at the Tech Savvy Talks, different presenters present different topics and the presenters are also specialized in different fields. So stay tuned for the upcoming events and yeah, enjoy. Before starting with the actual presentation, I would like to mention that this session will be recorded, and at the end of the presentation, there will be an interactive Q&A session. For the session, you can submit your questions through Slido. You will be able to find the session using the hashtag TechSavvy. So without further ado, let's begin. In the presentation, we will find out what is GitOps, what are its principles, its benefits. We will see how GitOps pipelines, what a sample GitOps pipeline might look like. We will explore the wonderful tool that is ArgoCD. And finally, we will have a short demo where we're going to try and configure and set up a working GitOps pipeline. So I guess we can begin. So first of all, what is GitOps? In its core definition, GitOps is a way to do Kubernetes cluster management and application delivery. GitOps works by using Git as a single source of truth for declarative infrastructure and applications. With GitOps, let me just, with GitOps, the use of software agents can alert on any divergence between Git with what's running in the cluster and check difference. Kubernetes agents automatically update or roll back the cluster depending on the case. And with Git as at the center of our delivery pipelines, developers can use familiar tools that they use every day to make pull requests to accelerate and simplify both application deployments and operation tasks on Kubernetes. So what are the principles of GitOps? The entire system is described declaratively, meaning with your application's declaration versioned in Git, you have a single source of truth. Your apps can then be easily deployed and rolled back to and from Kubernetes. And even more importantly, when an unforeseen disaster happens, your cluster's infrastructure can also be dependently and quickly reproduced. The canonical state, desired state, is versioned in Git. With the declaration of your system stored in a version control system and serving as your source of truth, you have a single place from which everything is derived and driven. This basically trivializes rollbacks and which can be achieved with a simple Git revert or a single click of a button, depending on which agent you are using. Using Git, you can get an extra benefit of having a look into the authors of the code and the pull requests, which is good for auditing purposes, I guess, and for seeing where the ownership is coming from for the code. Approve changes that can automatically be applied to the system, which means that every time that a pull request is opened and approved and merged, you're able to sync up your cluster automatically and make the deployment without the necessity to give direct access to anybody to the cluster itself. Software agents to ensure correctness and alert on divergence. This means that there's essentially an agent which always monitors both the current state of the cluster and the source of truth and alerts on any changes on either side of the configuration. So what are the benefits of GitOps? So increased productivity, basically continuous deployment automation with an integrated feedback loop speeds up the time to deployment. So enhanced developer experience, which means that developers can just push the code to Git and not worry about building containers or knowing the internal workings of Kubernetes or the configurations. This also makes it easier to onboard new members to our team and get them to start contributing relatively faster. Improve stability and higher reliability. Using Git to have more stable, reliable, and reproducible rollbacks. As we mentioned previously, Git is also the only source of truth. It's the alpha and omega, and it can help recover from disasters relatively quickly. Consistency and standardization. Finally, GitOps offers us consistency, meaning everything we have, our full workflow, including the application code, the infrastructure code, is built on top of our Git repositories, and it is managed through a single workflow. So speaking of Git workflow, we can also configure this to be achieved using GitOps, meaning that, for example, we have multiple clusters for multiple environments. For example, we have a development cluster, a QA cluster, staging, and production cluster, or even simpler, we have a development cluster and a production cluster. So we have configured that our develop branch will be synchronized with our development cluster, and our master branch, for example, could be synchronized to our production cluster. So every time we make a pull request to the development cluster and approve that pull request, the new change and the new source of truth will be applied to the development cluster. And when we are ready for release, we can just open a pull request from the develop branch to the master branch. And as such, we can then upgrade the production cluster to use the latest code as well. It is useful if we want to manage multiple environments and also have easy rollbacks on those multiple environments. So on this image, we have a simple GitOps pipeline. Basically, what it means is it contains two parts. The first part is where the developers actually commit the code change to the version control, and that triggers a build, which builds the Docker container and pushes it to the container registry. So the difference between this and the traditional pipeline is that we have a config updater here, which basically opens a pull request for the infrastructure repository to be updated with the latest image that has been built by the latest changes of the code. So when that pull request is opened towards the infrastructure repository, we can go ahead and merge it, and that will update the Git config files for the Kubernetes cluster. Meaning that the deployment operator inside of Kubernetes will detect that change, will detect that drift, will detect that there is a new image or new version uploaded and built, and so will then notify us about any actions that need to be taken. For example, if the cluster needs to be synced, or if it's set to automatically sync, we will look at this in our example that we will do soon. So first of all, before proceeding to the demo and the design, the architectural design for the demo today, I would like to talk about a little bit about ArgoCD. So ArgoCD is a GitOps tool that helps with your GitOps workflows. ArgoCD can be used as a standalone tool or as a part of any CI/CD workflow. ArgoCD works with Git as a source of truth with the current Kubernetes manifest. So it can manage also applications using kubectl or Helm. It can manage Helm charts as well. It can be managed declaratively through code, or it has even a nice dashboard, which we can explore a bit more in the demo. and it's really nice actually. It can be deployed inside of your cluster or outside of it, and it basically works as a general commanding an army and deploying and orchestrating and all of the good stuff. It is in the center of all of the GitOps workflow. There is of course some alternatives to ArgoCD. So for example, there is Flux, Jenkins X, and I'm sure there are a few others as well. But for the presentation, we will be sticking to ArgoCD. So this is the current setup, and this is what we'll try to achieve by the end of the presentation today. Sorry. So we have two GitHub repositories, one containing the application and the Docker file, and the build-spec.yaml file for the AWS code build. And the other one just contains the Kubernetes manifest files for the deployment and the service of a sample node application we are going to deploy. So how it works, the developers open a pull request towards the application repository, which then in turn triggers the AWS code build job, which builds the Docker container and pushes the Docker image towards Docker Hub, and in turn opens a pull request towards the infrastructure repository. It also is integrated with AWS SSM parameter store, where the credentials for the deployments, for the build, for essentially everything is stored, and it securely takes those parameters from the SSM parameter store without ever exposing them directly on any clear text format anywhere. We also have an AWS EKS cluster, which is deployed on one of our regions, and inside of that cluster, we have ArgoCD installed, which basically will allow us to do all of the automation stuff. So before we proceed with the demo, we have some pre-configured stuff due to the interest of saving time, because if we were to create the EKS cluster, we would spend the whole hour just waiting for it to be brought up. So we have configured the SSM parameters for security reasons. We can configure the EKS cluster to be created using the command you see on the right side of the screen. We have configured the code build role to use to have the ability to read from SSM parameter store and decrypt, and the two repositories, the sample application and the infrastructure repositories. I will share all of this and explain what is configured and how it is configured. So without further ado, here we can proceed with the demo. So first of all, we have two repositories. In one of them is the sample application. Basically, it has a Docker file, a package.json, and a server.js. It is just sample, nothing too magical. It is a simple application. It just has hello from Skopje. And we have a Docker file which runs npm install and exposes the application on port 8080. What else we have in the sample lab repository is the actual build spec file, which Cool Build uses to automate the build, the push towards Docker Hub, and opening the pull request for the infrastructure repository. So how it works is the following. It has the parameter store parameters. We have the Docker user, password, GitOps token, username, and email. And in the phases, it just installs some simple stuff like git and does an update. And it does also in the pre-build step log into the to Docker Hub using the Docker login command. So for the actual build itself, we have a Docker build command, of course, and a Docker push command, which takes in the following. Has the following image name. So it's my name, sample application, tech talk, and it takes in the code build number. And also for the push, it does the same thing. It takes in the image and it pushes it with the code build number. And here we are just configuring the username, password, email, and we are cloning the infrastructure repository which I will show you shortly. And it checks out a new branch with the build number, and it changes the image name of the deployment to be the new version. And then just we push the code, and in the post build we open a pull request using this post request with curl, which then in turn opens a pull request inside of this repository. So this is the infrastructure repository. If we go inside, we will see that there is only two files. One of them is a deployment and one of them is a service. Nothing special here either. We just have the image defined and an image policy, and basically we're telling it where the namespace, what namespace to look for. Let's go and move on to AWS, so we can see what is configured inside of AWS. So if we go to EKS, we'll see that we have, sorry, this is taking some time, so I will just load the other ones in the meantime. Okay, so in the Kubernetes clusters, we have a GitOps cluster, and that is a simple cluster, nothing too major. It is version 1.19, and it has 6 T2 micro instances, just to make sure that we have enough space for our application and ArgoCD to run in parallel, because T2 micros are really small instance types, but I didn't want to spend too much money on this presentation, so I just went with it. Inside of our systems manager, we have SSM parameter. We have parameter store, and inside of parameter store, we have securely stored parameters for the Docker path, user, email, username, and GitOps token, which is in turn referenced, if you remember, here in the build spec.yaml file. Other than this two, we also have a code build setup, which in turn just takes in this build spec, and it takes in this build spec and it builds the Docker container and it pushes it to the container registry, which is in this case Docker Hub. And that's pretty much the setup from the AWS side. And now we can proceed and see what we have deployed on the actual Kubernetes cluster. So kubectl get pods. So we have ArgoCD deployed. Again, this is in the interest of time, and I will share what has been done with the deployment. It is just referencing the official documentation for Argo. It is just a few commands that can be executed. You create a new namespace inside of Kubernetes and apply the official code, which is from reference from the documentation of ArgoCD, and that's pretty much it. The deployment has been created, and ArgoCD has been deployed in our Kubernetes cluster. And then we just retrieve the initial password with this command, and I can execute it actually and show you how it looks like. And it gives us back the first initial password that is automatically set when you install ArgoCD. So what we need to do now is, since this is not publicly exposed, we need to port forward to the pod of ArgoCD and log into the UI and see how that goes. So kubectl port forward to the server, which is this pod right here, port 8080 in the namespace ArgoCD. Okay, we're in, and we can go to localhost 8080, and we'll be prompted. Actually, keeps me still logged in. Okay, I can go through here, localhost 8080, and you get greeted by this nice smiling little octopus, and we can paste in the password just so I can show you. So this is the setup for ArgoCD. Right now we have no applications deployed, so we have nothing set. On the left side, we have a new application and another button, which is sync apps, which we'll talk about a bit later. So if we go to the manage repositories, options, we can see that we can configure clusters, projects, accounts, certificates, repositories. And if we go to the repository, you can connect your repository using SSH keys or HTTPS or authentication tokens. For this presentation, I can delete this. I think. Okay, we're just gonna keep that connected. I'll show you like this. So if you go, for example, using HTTPS, you will just need to clone the repository. So we are using the infrastructure repository for this. Something to note, because this is the part where we are doing the Kubernetes deployments, and this is the sample app is just where we are building the container. So the stuff that ArgoCD looks at is the infrastructure. So we can just connect it using this link, the URL, the username, for example, that you have, like sample login. And here you can just paste in your password or your personal access token. I know that there was some changes to the policy of how HTTPS connections are handled for Git. I think that now you need to paste in authentication token instead of a password. And that's it. You just click on connect and you will be connected. So next thing we need to do is go into the loading screen and create a new application. So this is where we will create the application. So we're going to new app. We'll give it node web. I think that's the name. And the project is the default because we haven't configured any project. We're just going to use the default setup for now. The sync policy, we'll leave it to manual, and I will show you how to change it later to automatic and what additional options we have with the automatic sync policy. For the source, we're going to choose our infrastructure repository and keep the revision as head, and the path is Kubernetes -node web. Is that correct? Just so we don't get prompted with any, yeah, it's node web. Okay. And the cluster ID, this is a local cluster since ArgoCD is deployed inside of our Kubernetes cluster that we are using. And the namespace, we will need to check what the namespace says. I do believe that it's a testing namespace, just to be sure. Yeah, it's the testing namespace. So we can go ahead. This is a wrong link. And go ahead here and select the testing NS namespace. And additional options for the directory is if you have multiple servers, for example, if you have multiple applications defined with Kubernetes YAML files in multiple folders on your repository, you can select this directory recursive, which will basically create all of the services in that directory automatically, so you don't have to add new apps for every single service that you own. So let's create this service. And that's it. We have the service configured, and we can see that it is out of sync, meaning that the service is defined on Git, but it is not actually present inside of our cluster. So before continuing, let's just create a namespace. So kubectl create ns testing ns, and this will allow us to deploy our application. Okay, it already exists. Yeah, so we already have that set up. And now we can just click, once again, let me kubectl get pods namespace testing ns. There shouldn't be anything present here. Yeah, so no resources found there. And if we click on sync and synchronize, the application will start deploying. So right now it is synchronized and the pod is being created. So let's check if that's true. And there we have it. The application has been configured and started. So we know that the deployment is successful. So what this does is basically allows you to have what we mentioned previously, to have a clear picture of how the configuration is on Git and how the configuration is on the EKS cluster. If you have any divergence, there will be an out of sync alert here. which will show us that in fact the configuration for the cluster is not in sync with that of Git. So what are other options do we have here? We have some application details, basically gives us details regarding how the application is deployed, what namespace, what cluster, which repository is it using, and which branch it is using, and all of the good stuff. And here we have the sync policy. So right now it is disabled, and after we make one more deployment showing the build process, I will enable that to be automatically, just so I can show you what are the additional options we have. So we have parameters, manifests, and events here. And this is an important button. If you go to history and rollbacks, every time a change is made to the application deployment, you will have a new revision here. So if you want to make a revert, for example, you made some mistake, you made some problem for the cluster, you can just go and select it and revert to that, redeploy that version, which is quite nice. And this is also this also can be handled through Git as well. So if you want to, you have the options to choose either from Argo or from Git. We have the delete option and the refresh option. The refresh option is basically just refreshing the page to show the new state. So let's go back to our cool build job now, and we can select it and start a new build, which will in this case build the application again with a new tag and post a pull request towards the infrastructure repository. So let's see how that goes. I'll try to tail the logs so we can see better. Usually takes about 30 seconds and so to finish the build and open the PR. Right now we can go into the pull requests and wait for it to be there. Okay, so yeah, it's just going through the build spec YAML file, pulling in, building the Docker container. And it will push the changes to the container registry, and finally at the post execution script, it will just open a pull request with the change of the image. There we go. So right now it's pushing the origin, and there we have it. So this is the confirmation that the pull request has in fact been created. And if we go here and refresh the page, we can see that the code build job opened an automatic pull request towards the infrastructure repository. And if we go to the files change, we can see that it is changed from 1 to 2 because that is the code build number of the execution. I ran one build before the presentation, and this is the second build for this project, as we can see. So it has added the appropriate number to the image, meaning that it is updated to the latest image. So let's see what happens when we merge this code. Okay, and merge and delete the branch. Okay, so right now we made 2 minutes ago, we made a change to the node web deploy, and we can see that we have the version 2. So if we go back to ArgoCD now and refresh the page, it will show that it is out of sync, meaning that it has detected that there is a change inside of the repository, and it is now alerting us that the desired state of Kubernetes does not match the one that is set up on GitHub. So again, if we synchronize, it will bring up a new container, and once it is up, it will just terminate the old container. So let's see. Yeah, so it is terminating the old container, and it is provisioning and running the new container, the new pod, sorry, not container. So let's go back to ArgoCD once again and see the history and rollback, and you can see here that we have 2 now deployments, and one is deployed 6 minutes ago and another one is deployed just now. And this is what I mean by reverting is easy. You can just go here and roll back to this deployment, and it will roll back automatically. One other thing I wanted to show is what happens if we go and enable the auto sync. So if we enable the auto sync, it gives us an extra option. So what is important here is the self-heal. So the self-heal basically, when enabled, allows you to have a fixed version where anything that is ad hoc made on the cluster itself will not be accepted. So for example, if we enable this option, if we were to delete some deployment or some pod or something, it will automatically revert to the latest approved and synced state. So let's just enable that and test it out and see what happens. Hopefully nothing will be screwed up. Just kidding. kubectl get deploy for namespace testing ns, right? Okay, so we have this, and it is created 6 minutes ago. And if we were to, for example, kubectl delete and deploy node web namespace testing ns, usually this would bring down all of the pods and the deployment, etc. But since we have auto healing enabled, what this will achieve is it will just recreate the latest approved state, and there will be no consequences from deleting anything ad hoc on the cluster, which is cool. And I think we have time to run one more time with the self-heal and auto sync enable. So what will happen with the auto sync? Let's go back to our code build job and run it again. And we'll give it one more minute, so we can open a new pull request for us. Again, this will do the exact same process, but in this time we have auto sync enabled, which will automatically deploy the newest code, which is merged into our branch for the Kubernetes manifest file changes automatically. And yeah, let's give it just a few seconds to finish. And this will free us up to not take any manual actions on the operator side, which gives way for automated workflows, which could be more complex than this. This is, again, just a simple application, just a simple deployment. But the possibilities here are huge. For example, it can the most use we got out of this one is in one of our previous projects, where we had a lot of ad hoc changes and ad hoc changes made to the cluster. And there was a time when we wanted to revert, but we were unable to, because the configuration on Git was very old, and the configuration of the actual cluster was with some ad hoc changes, and it caused a lot of issues. But with GitOps, we solved that, and we had everything in one place, and everything was in sync all of the time. So now we have the pull request open for the third build. And again, we are just changing the image name. If we go back and approve this pull request, let's confirm the merge and delete the branch, and go back again to ArgoCD and see what happens. And automatically it just synced, and it created the new deployment. If we go again and check get the pod, we will see that a new pod has been created, and that was done automatically by ArgoCD. So it was checking in the code, and it saw that there's a change, and it deployed it to the cluster.